GUIs in C++. GUIs in C++ are difficult. There are a lot of different GUI frameworks out there, but honestly, most of them are pretty bad. Take Qt for example. It's like Apple. If you stay inside their universe and use all of their tools, fine. But if you want to switch to a different build system or change anything else, joke's on you, so good luck on finding out all of the hidden flaws and finding out what you need to do to make it run. That's why I personally really like lightweight systems. Dear ImGui is a perfect example of a lightweight GUI, and it has virtually no overhead. It offers amazing features, is portable to pretty much any system, and still easy to use. So today we're gonna set up Dear ImGui for Ubuntu using Meson as a build system. We start with getting all the necessary prerequisites ready, and then we build the sample application of Dear ImGui. Afterwards, because I consider draw calls to be part of your ugly code, we will write an app framework that will implement a prototype app to hide all the nitty-gritty details. So you can afterwards focus on the real code and do not see all of the nitty-gritty details for the draw calls. So let's start. Here we see the repository of Dear ImGui. This is the official repository here, and you find a lot of information and a lot of README about it. So this is your top layer of your GUI. But because GUIs need a lot of different things as well, it's not enough to just clone this repository and get going. So you need to interface it with your system that you are currently running. That's why there are usually, for these GUI kind of framework, different backends, and we need to get at least one of those backends ready to start our GUI development. The backend that we're choosing today is GLFW. So GLFW is built on top of OpenGL, which means that it offers the OpenGL functionality. It has all the necessary calls to OpenGL, but it provides it with much more, like Windows support, like events, and all the stuff that you need to implement the GUI interface. And the third thing that we will need for implementing our GUI today on Ubuntu is Xorg. And Xorg is basically your window manager that is used on Ubuntu, and it's interfacing with your operating system and managing all the operating system calls in the background. So these are the three things that we need to install today, which is ImGui, OpenGL library, GLFW, and the Xorg foundations. Let's use our package manager to install these packages. We use apt-get, install, and we install as first GLFW, which is called libglfw3 because it's the third version. And here we need to confirm everything that we really want to install it, and we see now it is installed. The next thing that we need is the dev packages of that. Because we are writing source code, we need the dev packages to link against those libraries. So we will also install the dev package of that. The last thing that we need is Xorg, which is called install Xorg. And here we also need the dev packages because we, as said, write the source code and we want to link our source code against the library. After that, we need to clone the repository of ImGui because this is also what we need. So we can click here, and with whatever you want to clone, I usually use that one. We can then go to wherever we want to put it in, for instance, directly at our home directory, and then we can clone. And I think for me it says that I do already have cloned it. So if I'm looking here, you see that I already have ImGui on my PC. Now, since we have everything installed on our system that we need, we can start by trying to get the example application running. So if we are inside the ImGui examples, we see that there are pretty much examples for any kind of backend available. So this is the cloned repository of ImGui, and inside the examples folder, we do have here a lot of different examples, which all require a different backend. Today we will use the backend GLFW with OpenGL 3. So this is the example that we want to run. What I now did is that I copied this file here, the main C++ file, and put it in my folder and named it here OpenGL glfw example.cpp. So this is just the file as it comes with the repository. No changes were made, and you see it's a lot of messy GUI code inside, but hopefully it does the job, so I didn't change anything here. But we still need to include this in our build. So since we're using Meson to build our stuff today, I created a meson.build file. Here I named the project Dear ImGui, and I need to set up my include directories. So the compiler finds where the header and include files are. And here I say I want to link against a certain backend of ImGui. So this is where I cloned ImGui, and I need the backends folder of that, and I also need the normal folder of that, so I include all the ImGui files that I need. Additionally, since we are using GLFW, we need to have a GLFW library available, which is created here for Meson using the subproject call, and installing the library afterwards here in this subprojects folder. What I additionally did in the subprojects folder is creating here this wrap, because the library is not on my system, and usually GLFW doesn't offer the Meson interface, which why I just said that it needs to clone this library from the GitHub as well and provide it as name as GLFW. After setting this one up, we can also have the graphics library as a dependency, and that's basically everything. Now we need to create our application. So we gather all the source files that we need, and in the example it's told that we basically need all of these files. So we need the backend for OpenGL 3, we need the backend for GLFW, and then we need the demo, because we want to build the demo code of ImGui, and all of the different stuff is related to the demo code. And this is the file that I've copied, which is the OpenGL GLFW example. And then we bundle all of them together and call them example. So we can now build the example app, and this one here is for later. In this folder, we then need to create the build directory, which we use Meson build here for, and we also have this native file here. And the native file is just containing information like the C++ standard, the optimization level, which compiler to use, and so on. So we go here and we create that one. And here we also see that the subproject is getting downloaded, and we get here this GLFW folder, and everything seems to be working. So we can use Ninja to build our application by using ninja-c build here. And as you remember, we called the application example. So we built the example application, and we see it's already getting started. So depending on your system, this might take a while because it's a quite big framework of ImGui, and especially the code for the framework might take a while to compile. So everything is ready, and we can run the example by going into the build here and calling here example. And here we are. This is our first GUI example using GLFW and OpenGL 3 and using Dear ImGui. So you see here inside there's a lot of the different things that you need to do, some of the configurations that you might have, and also a little bit of examples. So any example code that you want to find here, you can find. So it's really a great way to see how they are doing it, because the source code for all of this is available, and you can have a direct look into the source code to understand how it works and to adapt it to your own needs. But let's look at the actual source code of this file. So we see here we have inside of this file a lot of boilerplate code. So of code that you need, but that you don't really need to understand, or that you probably don't want to understand in such detail, but you still need to do it. So there's a main file here inside, and inside this main file we do have all of the different creation of the windows, creation of the frame buffers that we need, all of the different setting up calls to the graphics engine and so on. And then inside we do have a big while loop which is running until our window gets closed. And this is basically polling all the events. So what has happened? Did somebody click? Did somebody move a window or something? And then it's creating all of the different GUI elements that you want to display. And afterwards, it's then doing all this necessary rendering. So it's actually calling then the graphics card. And then it's creating your output frame buffer and swapping the frame buffer with what is currently there. If you decide to close the window, you need to clean everything up, and that's basically it. However, if you now want to create an application using exactly that code, it's really messy, because you don't see really where is your logic, you don't see really where is your application. And that's why we create now an app framework, which is hopefully making things a little bit easier. The basic design of this app will be as follows. So we use C++, and that's why we also create a class for that. And during the constructor of the class, we will set up everything that we need to draw. During the destructor of the class, we do all of the necessary cleanup. And during run, we separate basically in two different states, which is we have a startup, and the startup is creating everything that needs to be done exactly once. And the main loop itself, where we will have some sort of condition here, will then just update. So your app will have a certain tick which updates it. So usually GUI apps, they have something like that, specific FPS counter or something, where every new frame that you get, you execute all the logic in the background. Even though this is possible for small apps to have it exactly like that, for bigger apps with much more logic, it even makes sense to do the calculation in different threads or something. But this is not something we will look into today. So yeah, this is the basic structure of the app, and now we need to fill it. For filling this, we go back to the example that is delivered with Dear ImGui, and we just copy the code, right? So we take basically the same examples that we want to have, or the same includes and so on that we want to have, because we will for sure need them if we also need the code. So we put the code at the beginning with all the includes and the error callback, and then we go back into everything that is setting up the window. And setting up the window is all the code up until here, and this is basically setting everything up until it gets repeated. So we use this code and we put this code in our constructor. So here we set everything up, and then we also restyle it nicely. And now, after the constructor has been called of this app, we know that the graphics system is set up. The second step, what we need to do is we take the same condition here for the while loop, we put it here also in our while loop, and then we need to call the graphics after everything. But since we want to be able to draw to an actual frame in our framework, we move everything until we create the frame, which is at this point. This we move before the update, right? So in the update function of our app, which then the user can implement, we already have the frame available, which means that we can already issue draw calls, we can already put some GUI inside. After the update, we need to render everything that is inside, and then swap the buffers. And now you see I don't copy the application or the demo code, because this is just rendering the demo stuff that we don't want to have in our framework. So we render here the demo code, or we don't use the demo code, we just use the rendering of the demo code, and then we're basically done, right? Or maybe not. So you already see that here the window is somehow, it's not there, because during our run we don't have the window, because the window gets created in our constructor. So this window here is something that we need to store probably as a private member of our class. And this is exactly what we're gonna do. So we put here a private member of our class, which we call a window pointer. And now you see that the window already exists. And here we need to remove the declaration, so it really is moving or using the correct window. Now we do have a pointer to something, so probably we should also clean this up at some point. And this is then here the cleanup, and the cleanup code is the code that we will put into our destructor. And this is also really using this resource acquisition, this initialization technique from C++ very nicely, which is also basically the window gets created in the constructor and it gets destroyed in the destructor, which means we are always in a valid state. Now, one thing that we also need to have here is a clear color, which is just the color of your background. So it also does make sense to put the clear color as a private member of the class. And then we also have the clear color here available to put it as a background color in our app. As a user, you can now just derive from this app class, and then you can do the necessary calls that you want to do without needing to worry about all the overhead. So what we're gonna do is we will rebuild the example. And here in the example, we have these three things. It's like a demo window, so we just want to show the demo window. And probably, here's some text boxes or show another window. This is what we will basically do. So we create here the state, and then we put the state here as private somehow. And then we will use this here and just copy it inside our update function, because the update function, as we know, is already called inside the frame that is created. So we already have frame available, we already have created everything, and we just need to worry now about the draw calls, which is pretty much cool, because you don't need to worry about anything else, about setting up your stuff or whatever, right? The main afterwards is also pretty straightforward. It is creating now my app, because this class here is now called my app. And here it is creating an object of my app, and then it's simply calling .run, which is then executing all of the stuff that we put here, and afterwards returning 0. So it's a really small main, and you should also try to keep your main small like that, because it's just it's good style, right? To compile this code, we have here a second part of the meson.build file, which is now using the main.cpp, which we have just filled, and also using the dependencies of ImGui, and creating then an executable, which is called App Framework. Now we can use this to build the code. So we go to the build here and build App Framework, and we see it's still failing because there are some issues in the code, and let's have a look at that. So it's calling that in our app design, we are returning from our constructor. We should never return values from our constructor, but this is because we copied the code. And here we see that we have here still some return 1 values, which were basically the return, as you remember, was part of the main. So usually the main here would have exited. So what we will do here is we will replace it by a standard exit function. And we will do here at this point exactly the same by also using standard exit, because this is also what would have happened in the main code before that. Additionally, we see that apparently clear color is used in one of the examples, but right now it's a private member. So let's just make it public. It should not matter at this point, right? So let's compile and hope now that it works. And we see, yes, it works. And then let's run it, right? So we go to build tier and we have named it App Framework. And here we can run App Framework, and we see it's now also the same example as before, but in the code, it's now a much nicer structure, because here in the code, we have now hidden all of the nitty-gritty details into this app design class or into the app design file and into the class called app. And in our app implementation here, we only have the real draw calls. So the real things that we actually want to draw. So this is a lot less code. And the nice thing is now this app here can be reused for any example. So we can write another app with different calls and different things that we want to render by reusing here this app design class. And in fact, this is what most app frameworks are about, to really hide what is common for everybody and then to extend it with what you actually want to specify on your own. But we wouldn't be in C++ if we wouldn't care about performance. And doing this kind of abstraction actually imposes a performance penalty on us. This means that, for instance, here we do have this update function, and the update function gets repeatedly called, but the update function is virtual, which means that every time we call the update function, we have an overhead, and we have an overhead that we didn't have before, which means that actually here now this abstracted code is less fast than the code we had before. And we don't want to have that, so we want to always have fast code, otherwise we can use Python or something, and we don't need to use C++. So let's fix this. The main issue here is that we're using virtual functions, and we can use CRTP to get rid of those virtual functions, because we will never really create something like an app interface where we store multiple apps in a vector. So we can easily template that one, and this is what we're gonna do. So we will use a template, type name derived, which means that our app will afterwards know of our derived class. And then what we will do is we will actually implement those functions. And here we can remove virtual because it's not virtual anymore. And here also we can remove virtual, and we will implement here the functions as a CRTP call. So we will just call static cast to derived, which means that we will cast ourselves to a derived pointer and call update on the derived class. And here the compiler is able to optimize now everything away and to inline it as we would call the update function of our derived class directly without any overhead involved. And here we can, for startup, we can do exactly the same. We can also do a static cast as a derived pointer of ourselves, and then we call here not update this time, but we call startup. And by doing it like that, we have eliminated all the overhead that we had before. In our implementation now, we need to adapt it a little bit, because here we now see that the template argument is missing, and what we will do here is we will now use here my app. And we now also need to get here rid of virtual and final, because those functions are not virtual anymore. They are now called via the CRTP interface. And here my app doesn't have any template parameters, so it's all right. And we can compile the code, and it should work as before. So we see it's already compiling. We shouldn't see any difference, The difference probably is somewhere in the background, where we now achieve a much better performance of our code, and we now have this nice abstraction of the app framework without spending any penalty on performance. I hope you have learned something today and you have enjoyed the content a little bit. If yes, please hit subscribe. I still think that Dear ImGui is a very great framework to implement performance relevant GUIs. So it's really easy to use and it's really portable. So you can use it on any system if you use the right backend for your code. It offers you with everything that you really want to have in a GUI framework, but it's still really, really lightweight. So I really enjoy it. If you also enjoy it, you can get the code that we have written today from GitHub. Just go to my site and go to the GitHub and clone the repository. If you enjoyed the content, hit subscribe. And if you want to stay on here and keep watching, I think this is a great video that you might find interesting. And as always, thank you for watching. And the most important part, enjoy coding.